All right, if you're diving into the world of data with Python, whether it's data science, machine learning, you name it, there's one library you're going to hear about over and over again, and for good reason. Today, we're jumping into your beginner's guide to NumPy. So let's start with a really basic question. Have you ever been working with a ton of numbers in Python, and it just felt a little slow, a bit clunky? Well, you're not imagining things. There's a reason for that, and it's the perfect setup for why NumPy is such a game changer.
And this really gets to the heart of it. On one hand, you've got your standard Python lists. They're super flexible, which is great, but that flexibility has a price. They can be slow, and they eat up a lot of memory. Then you have NumPy arrays. These things are built for one thing: speed. They're way faster, much more memory efficient, and just pack so much more power when you're crunching numbers.
Yeah, think of it like this. If a regular Python list is your standard car, NumPy is like hitting the turbo button. It's the power-up that takes your number crunching from, okay, this is working, to, whoa, that was fast. It's the solution for high-speed numerical computing.
Okay, so what is NumPy really? Well, the name kind of gives it away. It stands for Numerical Python, and it's pretty much the fundamental library for doing anything scientific or numerical. Its whole job is to give you these super efficient tools for working with big, multi-dimensional arrays and matrices. Honestly, it's the bedrock of data science in Python.
So, how does it pull off all this speed? What's the secret sauce? Well, first off, it uses these incredibly efficient data structures, perfect for things like grids of data, matrices, you name it. Plus, it makes doing math on every single item in an array super simple, no need for clunky loops. But the real magic? Under the hood, the heavy lifting is done by code written in C and Fortran, which are ridiculously fast. That's why pretty much every other data science library is built right on top of it.
All right, that's enough theory. Let's get our hands dirty, right? It's one thing to talk about how great it is, but it's another to actually see it in action. So let's turn some of those plain old Python lists into these supercharged NumPy arrays.
First things first, before you can use any of NumPy's power, you've got to bring it into your project, and you'll see this line of code everywhere. We just say import NumPy as np. That np is just a little nickname, a standard shortcut everyone uses. It just makes the code cleaner and easier to write.
Creating your first array is unbelievably simple. You take a normal Python list, just numbers and square brackets, and you feed it to the np.array function. Boom! You've just converted a regular list into a powerful, one-dimensional NumPy array. It's really that easy.
But let's be real, data is rarely just a single line of numbers. It's usually in a grid, right? Like a spreadsheet or a picture. NumPy handles that just as easily. You just give it a list of lists. And just like that, you've got a two-dimensional array, basically a matrix. In this case, we've made a nice little 3x3 grid.
Okay, so we've made this thing. Now what? How do we know what we're working with? Well, NumPy gives us some really handy attributes that let us peek under the hood and see exactly what our array looks like.
For example, if you want to know how many dimensions it has, you just ask for .ndim. For that 2D array we just made, it correctly tells us 2. Simple as that. We know we've got rows and columns.
And if you want to know the size of those dimensions, the .shape attribute gives you that. The result 3, 3 tells us it's exactly 3 rows by 3 columns. Super useful for a quick check.
And finally, if you just want the grand total of all the elements inside, .size gives you that number straight up. 9. See? These 3 little tools are your go-to for quickly getting a feel for your data.
So, why do we care about all this? About arrays and shapes? Because this is where the magic happens. This is where you see how you can do some really powerful calculations with surprisingly simple code. This is the payoff.
Okay, check this out. With regular Python lists, if you use a plus sign, it just smashes them together, end to end. But with NumPy arrays, it does what you think it should do. It adds the first numbers together, then the second numbers, and so on. It's called element-wise addition. One simple plus sign does all that work for you.
And it gets even better. Say you want to double every single number in your array. Normally, you'd have to write a loop to go through each one. With NumPy, nope, you just multiply the whole array by 2. That operation gets broadcast to every single element automatically. It's so clean, so readable, and so incredibly fast.
And just like with addition, if you multiply two arrays, it does it element by element. First times first, second times second, you get the idea. Again, a single, simple operator for a really powerful calculation.
And believe me, this is just scratching the surface. This little table is like your starter pack. We've seen how to create arrays and do some basic math, but you can also get things like the sum or the average of all the numbers, and even do complex stuff like matrix multiplication, all with these simple, intuitive commands. It's seriously powerful.
Okay, let's take a step back for a second. We've been in the weeds with the how, but let's really hammer home the why. Why is this so crucial to learn? Because NumPy isn't just another library you can learn. It's the actual foundation for pretty much the entire data science world in Python.
And you don't have to take my word for it. This quote really says it all. NumPy serves as the foundation for many data science and machine learning libraries. The key word there is foundation. It's what everything else is built on.
So if there are just 3 things you walk away with today, let them be these. 1. Speed. For number crunching, it blows regular Python lists out of the water. 2. Power. It makes handling complex, multidimensional data feel easy. And 3, and this is the big one, foundation. It's the building block for other essential libraries like Pandas, SciPy, and Matplotlib. When you learn NumPy, you're basically learning the language of data in Python.
Look, we've only just begun to explore what's possible, but you now have the fundamental building blocks. You know how to make arrays, and you know how to perform calculations on them. So I'll leave you with this question. Now that you know the basics, what's the first problem you're going to solve with NumPy?